Hi, welcome to our lecture 2 on organic molecules and structures. Please subscribe to my YouTube channel at Weniswa Chem. Our lecture 2 on organic molecules and structures, we will focus on the empirical and molecular formulas and its applications. Please subscribe to my YouTube channel at Weniswa Chem, and you can reach me on email prince.owusu@yahoo.com or LinkedIn Prince Owusu Echam. Our study outline, as I said, we will know the empirical and molecular formulas in their application. And last is that we will get to know structural formula of a compound. Empirical formula. The empirical formula of a compound is the simplest whole number ratio of atoms in each element present in a compound. An empirical formula does not refer to isomerism, structure, or absolute number of atoms. Note, the simplest whole number in empirical formula is 1. That cannot be divided by a common denominator. Please, we should know this statement very well because we are going to apply this sentence. Note, the simplest whole number in empirical formula is 1. That cannot be divided by a common denominator. The empirical formula is used as standard for most ionic compounds such as calcium chloride, CeCl2, and macromolecules such as silicon oxide, SiO2. The term empirical refers to the process of elemental analysis, a technique of analytical chemistry used to determine the relative amount of each element in a chemical compound. For example, the chemical compound normal hexane has the structural formula Ca3, Ca2, 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 and Ca3, which shows that it has 6 carbon atoms arranged in a straight chain and 14 hydrogen atoms. So the number of carbon here is 1, 2, 3, 4, 5, 6. And our hydrogen atom is 3 plus 2 is 5 plus 2 is 7. 7 plus 2 is 9. 9 plus 2 is 11. 11 plus 3 is 14. Hexane's molecular formula is C6H14, and its empirical formula is C3H7, showing a CH ratio of 3:7. Here, we will note that from the sentence, the simplest whole number in empirical formula is 1. That cannot be divided by a common denominator. So if you look at this formula, 3 and 7, 3 and 7, no number that can go into 3 and also 7. But if you look at this one, we will have a certain number that can go into 6 and also 14. In this case, this is how empirical formula is presented, and this is our molecular formula. Because in molecular formula, we will have a common denominator. Yeah, we will have a common denominator. But in empirical formula, we cannot divide by a common denominator. So different compounds can have the same empirical formula. For example, glucose, formaldehyde, and acetic acid, with a formula of Ca2O. This is the actual chemical formula for formaldehyde, but acetic acid has double the number of atoms, and glucose has 6 times the number of atoms. So this is the representation of formaldehyde, CH2O. This is formaldehyde. This is acetic acid. Acetic acid is CH4O2. And this is glucose, C6H12O6. Molecular formula. Similar, a formula that expresses the actual number of the various atoms present in the molecules of the compound. Unlike the simpler empirical formula, which only specifies the relative number of atoms or moles present in a compound. Note, the actual number in molecular formulas can be divided by a common denominator. The actual number of molecular formulas can be divided by a common denominator. Consider the compound below. For the compound, we have 9 carbon atoms and 18 hydrogen atoms. So let's count our number of carbon and hydrogen. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. And our hydrogen atom, we have 3 atoms of hydrogen here. 3 plus 3, 6 plus 3, 9, 10, 11 plus 3, 14. 14 plus 3, 17 plus 1, 18. The molecular formula is C9H18. These formulas are traditionally written with symbols for each element followed by a subscript indicating the number of atoms in the molecule. So we can see C subscript 9 and H subscript 18. It means that the carbon atoms are 9 and then the hydrogen atoms are also 18. So the numbers are written in subscript mode, and then we have our normal capital or our formula for the elements. For example, water molecules has a molecular formula of C. It has a molecular formula of H2O. Specify that each molecule contains 2 hydrogen atoms and 1 oxygen atom. For instance, glucose molecular formula C6H12O6 specifies that each molecule contains 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. In contrast, the empirical formula for glucose is CH2O, which states that there are 2 hydrogen atoms for every carbon atoms and 1 oxygen atom for every carbon atom in 1 molecule of glucose. Molecular formula continue. To create a molecular formula, the molecular formula and empirical formula of a molecule are related using the expression MF, which is the molecular formula, which is equal to N times EF, empirical formula. So to find molecular formula, you need to know the value of N. So we will multiply the value of N by the empirical formula so that we will get our molecular formula, where N is a positive whole number. The value of N is usually determined by dividing the molecular mass by empirical mass. The molecular mass is the sum of the atomic masses of all atoms in the molecular formula. So we found our molecular mass from molecular formula, and we found empirical mass from empirical formula. The empirical mass is the sum of atomic masses of all atoms in empirical formula. The expression M molecular formula is equal to, here we will have, this is molecular mass. Molecular mass is equal to N times empirical mass. Related the molecule's molecular mass, that's MM, to its empirical mass. A compound's molecular formula is always an integer, multiples of its empirical formula. Yes, if the empirical formula of a compound is known, the molecular formula can be determined experimentally by measuring the compound's molecular weight. Some compounds share the same molecular and empirical formula, such as methane, CH4, which has both empirical and molecular formula of CH4. So some common examples we will know we have our substance molecular formula, empirical formula. Water has molecular formula of H2O and empirical formula the CH2O, methane CH4 and CH4 for this. Benzene has molecular formula of C6H6 and C6H12. Sorry, this is C6H12 and they all come from CH. Our sulfur will have S8 and our empirical formula is X. And glucose, we have C6H12O6. So they are coming from CH2O.